In this example, we will demonstrate use of the Time-Sweep DPL script to carry out a time-sweep analysis. Activate the study case Time-Sweep Analysis in the Project Overview window. Here you can see the 400-volt network. Use diagram colouring to show all the feeders in this network. You can see that only one feeder has been defined. Zoom in on this region of the network. You can see that connected to this feeder there are a number of loads and a number of static generators. Take a closer look at one of the static generator objects. On the load flow page, take a closer look at the active power parameter. Right-click in the box where you enter the value. You can see that there is an option there to select Edit Characteristic. A characteristic has already been defined for this particular parameter for all the static generators connected to this feeder. You can take a closer look at this characteristic. Here you can see the values that have been applied at each hour of a particular day. You can look at these visually by selecting the diagram page. Now take a look at an LV load. Right-click in the parameter scaling factor and select Edit Characteristic. You can see that for these objects, a characteristic has also been defined. You can see that the scaling factor is varying throughout the day. We will now use the DPL script Time-Sweep to carry out a series of load flows throughout each hour of the day, taking into account the characteristics that are applied to particular objects. Find the feeder in the object filter. Right-click on the feeder and select Execute DPL Scripts. Find the Time-Sweep DPL script and select OK. The script will carry out a series of load flows where the time of each load flow is varied from 0 to 24 in steps of 1 hour. Execute the script. Here you can see two plots of the 24-hour analysis are shown. The first plot shows the feeder losses as a function of time, and the second plot shows feeder generation active power, feeder total load active power, and feeder in-feed active power as a function of time. If we maximize the output window, you can see an energy summary is reported. Returning to the plots, let's define two y constants. Show all static generators in the network. Change the number of parallel generators in each generator from 1 to 10. Rerun the DPL script. You can see that the results have changed significantly, reflecting the increased amount of generation in the network.